All right, so in this topic, we're going to be looking at different types of graphs. And so what I'm going to focus on for today's video is something called a pictograph. A pictograph is a graph that illustrates data using pictures and or symbols. So I've got an example here where I'm talking about video game platforms that could be owned or used or owned by grade 8 students. And I've just kind of gone off of previous data from things that I've taught in the past, knowing that most students seem to prefer the Xbox, which does seem to be crazy. I don't know why anyone would do that. Clearly, PlayStation's the way to go. So looking at this here, I've used a picture instead of numbers to say how many students have each type of video game system. So if I'm looking at the PS4, I've used 1, 2, 3 video game controllers to represent how many students own that PlayStation 4. Now if you look at the legend in the corner here, it says one controller represents 4 students. So that's what I'm going to be looking at when I see a controller. So every time there's a controller, that's 4 students. So this controller represents 4, and this one represents 4, and this one represents 4. So in total, I have 4, 8, 12 students who had the PS4. If I look at the Xbox One, 1, 2, 3, 4, 5 students, 5 controllers there, and that's 4, 8, 12, 16, 20 students in total who would have an Xbox One. Okay, so that's the way a pictograph works, is we are just using a symbol or a picture to represent the number of students instead of just an actual number value written down. Now, there are some good things and bad things with pictographs. So pictographs are really awesome when the numbers or the data are easily countable. So if you think of that last example I gave you, I said each controller was 4 students. And that means that my data really worked out nicely. They were all multiples of 4. So it was really easy to say 4 students to a picture, and then I can use that picture to show all the data. Okay, so when the data is easily countable, a pictograph works really nicely. It's a very quick way to compare which group is the biggest or the most popular. So if you look back really quickly, it was very easy to see that the students, most people had the Xbox One. That was the largest grouping. Okay. It's also very easy to visualize, right? Having those pictures makes it easy and maybe more accessible for people to understand what's going on in the graph. Now, some downsides of a pictograph: they really are almost unusable when the data is not easily countable. So I will show you quickly at the end here how I could make data not easily countable and then how it just will not work nicely as a pictograph. And while it doesn't state the totals, right, so I had to do some counting to figure out how many students had the PlayStation 4 and how many had the Xbox One. It doesn't necessarily state the totals, but it is still fairly simple to get them. Now that is different, right? You might have a graph like this where you've got the x-axis and your y-axis, and if it was a bar graph where the bar goes up, it's really easy to see, well, the top of it's here, where does it end up on my y-axis? It's very easy to quickly see the total number there. So that is kind of a disadvantage. But again, because our numbers are easy to count, it's not too difficult to figure out how many students have the PlayStation 4, Xbox One, or each thing individually, right? So when I'm looking at the PlayStation 4, again, 1, 2, 3 controllers. Each controller represents 4. 3 times 4 is 12. Or I can simply count by 4s, right? So 4, 8, 12, 16, 20, right? 4, 4, 8, 4, 8, 12, 16. So it is fairly fast to count, okay? And it's easy to see which group is bigger than the other. Now, how we make a pictograph, okay? So with something like this, I'm going to create a pictograph for this data. So here we go. I've got my favorite pizza toppings, or favorite pizza toppings of grade 8s. And again, based off of what I remember from when we used to be able to have things like pizza parties in the school. So we've got pepperoni, Hawaiian, cheese, and vegetarian, and always a surprising number of students like just plain cheese pizza. You guys are crazy. Now, yes, I'm aware there are more pizza toppings than just this, okay? And obviously, I'm not including everything. This is a made-up example. But the nice thing about my numbers here is, look, 12, 6, 9, 3. These guys are all multiples of 3. And because they are all multiples of 3, that means they are really easily countable. So what I could do is I could use a picture instead of using those totals. So I've got this piece of pizza right here. Why don't I say that this piece of pizza, since they are all multiples of 3, that single piece of pizza represents, did it disappear on me? That single piece of pizza represents 3 students. So I'm going to, instead of writing 12 for pepperoni, I'm going to take 1 slice of pizza and drag it up here. That represents 3 kids, but I need 12. So I have another piece of pizza. That's 2 groups of 3, so now I'm at 6. 3 slices of pizza. That takes me to 9, 3 groups of 3. And a final slice now gives me my 12 students all together. Right? 3, 6, 9, 12. Each slice represents 3. So I simply use my picture and I drag it in. So for Hawaiian, there is 6 students. So I need to have 2 slices of pizza. And notice when I'm dragging them in, I'm doing my best to line everything up so that everything is equal. Okay, I want it all starting at the same spot. And we'll talk more about this as we go through our topic, but I want everything to try and be lined up and equal. I'm doing the best that I can on the tablet. So there were 9 students who like cheese, so I need 3 groups of 3. And I've run out of pizza slices, so I'll have to duplicate. And those vegetarians there. 1 slice of pizza. So again, we can see really quickly the most popular is pepperoni. That has the most slices. That means the most students prefer pepperoni. I can see the least popular, vegetarian, right? Only the 1 slice, so only 3 students like that one. These guys are kind of in the middle, but it's easy to see which is the most popular, which is the least popular. It's very easy to count. I count each slice as 3, so 3, 6, 9, 12 total for pepperoni. So it is fairly easy to count. Now, how could I make this so that a pictograph no longer works? Well, if instead of vegetarian being 3 students, if all of a sudden it's 4, this totally falls apart. I now don't have all multiples of 3. I don't have a way of representing this nicely. The only thing I would be able to do is perhaps do 1 slice of pizza represents 1 student. And yeah, that's easily countable, but it seems kind of unwieldy to have to put 12 slices of pizza. It's not really saving me time. So that changing that from 3 to 4 makes the data uncountable, okay? It's not easily countable by a nice multiple. So a pictograph works really, really well when all your numbers are a multiple of something. But as soon as that data changes just that one little bit, it really messes things up. All right, there's pictographs.